To be honest, are we doing the bell right now? It's that's 1, now 6. It's negative 10. It's also
Okay, Coulomb's law is what we're going to talk about today. Then we're going to apply Coulomb's law. We're going to do some vector additions like we did way back in chapter 4. It'll be fun. Okay? When you have two charged objects and they come near one another, they may experience an acceleration either due to attracting or due to repelling. Okay? And we know that acceleration is the result of a what?
Change in direction or velocity.
Okay, that was too broad of a question. What causes an object to accelerate? Force. Okay. All right? Yes?
Quick question. If we put the equation on our note card, can we write the word electric? Or no?
What? It's kind of obvious. You want to do it?
We can't put FE because we don't think it's iron.
Yeah, no.
We think it's.
Okay? So, two charges that come near each other are going to exert a force, and we will call it an electric force. So, what determines how small or large the electric force will be, do you think?
The size of the
What did you say?
The difference in magnitude of the charge.
Okay, the charge's magnitude, what that simply means is how much charge each of them have, right? If you had a 3+ charge instead of a 5+ charge, the 5+ charge is going to exert a greater force, right? Okay, and the distance from each other. So the two things that are important for finding electric charge are how strong the charge is and how close the charged objects are to each other. And you're going to see that in the equation here.
Isn't this equation like the same as the planet one?
Yeah, it's very similar. Yeah, there's a lot of similarities. Because you're going to find that gravitational force is similar to electric force, and is also similar to magnetic. They're field forces, and they act very similarly to each other.
What were the two things? Is how strong the charge is.
How strong the magnitude of charge is, which is what Q is going to be, and how close the objects are to each other. Okay? It would make sense. The closer two positively charged objects come to each other, the more force of repelling they're going to have, right? And the closer a positive charge and a negative charge are to each other, the stronger the force of attraction will be. Like if I have a charge right here and I have a charge at the other end of the school, are they going to have much of a force acting on them? No. Unless they had a really strong magnitude. Alright? So what you're going to find here is that your distance is inversely related to your force and your charge is directly related to your force. Okay? Alright? Your constant, do you have the constant in your notes or do I have to write it down? The KC.
Does God have it? We don't 1.6.
Okay, it's 8.99 times 10 to the 9th Newton times a meter squared divided by a Coulomb squared.
There's no short. The whole thing.
You're going to see what's going to end up happening is a meter squared will cancel out with a meter squared here. And these two charges are in coulombs, will cancel out with the coulombs, leaving you with newtons, which is what you need for force.
Right.
Is that the?
Is it all?
It's just meter.
It's just meter.
It's just meter.
You actually saying
not
she's saying it's the whole thing divided by the c squared or just the meter squared?
Well, we easier just to use. So yeah, instead of the whole thing, but I usually just. I mean, if you want to put slash and then c squared, that'd be the same thing. Yeah, that's fine. Oh wait. Huh?
That's the constant, right?
Yes, that is a constant. For all electric charges, you're going to use that when you're trying to find the electric force. Alright? Okay. We are going to deal with the forces on electric charges just like we dealt with forces on an irregular object. If you have multiple forces, you have to add the vectors.
Oh.
And so what we're going to do is we're going to have multiple charges, and we're going to figure out how the forces on one of the charges is going to interact. Okay? Today's problem will be difficult. Yes?
Are we coming back to this math equation?
Yes, barrels.
Yeah, yeah, I'll do that before I do the second more difficult. I want to get through all the notes and then we'll do the math. Okay? So, if you remember the resultant force just simply means the vector sum of all of the other forces. Okay, so if I had a positive charge, a negative charge, and a positive charge, these two charges are going to exert a force on this one. Okay? Which direction would the force on this one as result from this one be? Up. Okay, because they what?
They're repelling.
Repel. Okay, what would be the result of this based from this? So we would have to take the vector sum of those two vector arrows. Okay, which is what we're going to do, but just give you. Yeah, the resultant will be diagonal because I will go right tip to tail.
Isn't that gonna like if the negative is close towards that?
Yes, technically you're saying won't these affect each other? Yes, we're gonna say that they don't. They're just gonna affect this to make it easier, just like we reduce friction and make everything's in a vacuum. All right, let's do the first problem that's a little bit easier, and then we'll do the more difficult one.
Adding Portland's weight is the principal superposition. No, that's the test question.
All right. Okay, then there's a lot of information that they don't give you in this problem that we have to search and find out, but we'll be all right. Basically, the electron and proton of a hydrogen atom are separated on average by a distance of.
That's oh, or.
Okay, find the magnitude of the electric force. And the gravitational force.
We have two variables, that doesn't make sense.
Okay?
Oh, here's the constant for gravity.
Oh, 6.67.
So we have our F electric
That's right.
is our KC.
Wait, why is F electric that? These are in the equation. Isn't it Kc?
I'm writing what KC equals.
No, he's writing it.
You're eating a little bit.
He's throwing in KC and then he's going to do fractions.
So then we got to figure out what Q1 is and Q2 is. All over R, we know what. I'll just write this in for now.
We do R squared. Squared.
Okay, so in our R was 5.3 times 10 to the negative 11.
Frames, the Kc isn't over R.
Yeah,
It doesn't matter. The Kc, yeah, wait.
The
It doesn't matter.
If you're
Multiply, so
multiplying,
it's the
it's
same thing.
Kramer?
Like, just like in the gravitational equation, a lot of times they go G and then they go M over R squared. Usually we just throw the G on top because you're multiplying.
I thought
That
FG
doesn't,
was.
oh, I guess I wouldn't throw off your order numbers.
FG.
Kramer, why is it not a constant?
What?
FG.
This is not.
It hasn't been a constant all year.
Acceleration due to gravity has, but not the force due to gravity.
Because remember, the force due to gravity changes.
So 9.81 is the acceleration.
It's also not a constant.
That's how much all objects accelerate, but because there's other variables like mass, it doesn't affect how much force it has.
I thought he played it on.
I'm usually pretty smooth.
Also, that.
Not when you have a loud sound.
radius
It's
on
like,
Now, do we know, so we said that our particles here are a proton and an electron, right? Do we know the charge of a proton and an electron?
Yes.
Oh,
Yes.
It's positive and negative.
Okay? So a proton is 1.6 times 10
Oh.
to the negative 19, and an electron is negative 1.6 times 10.
Why always be that way then?
We're talking about a proton and an electron, but that's not the only charged particle we'll talk about.
Positron.
Also, your radius should have.
It's like a younger version of myself.
Thank you guys.
No problem.
Okay, so when you plug this in and you solve, because it wants magnitude of the electric force, I'm going to actually ignore any negatives. So So we should get 8.2 times 10 to the -8 newtons.
Why does magnitude not be
Because magnitude is the amount, not the direction. Remember how we talked about vector quantities versus scalar quantities? Magnitude and direction is vector. If they just want magnitude, that's
Can't we
without
just make
direction.
Is this it?
Q squared law?
Yeah,
Or-
but it won't always be the same number. So I wrote it all out. Because the next problem we're going to do is we're going to have 3 different charges and they're not all going to have the same charge.
What do you mean charge?
Coulombs is our charge.
I got you, it's a little off, I got 8.5.
Okay, the magnitude of how strong the charge is. A proton and electron's charge isn't very strong. But they're tiny objects that actually, well, I would say they're actually fairly charged compared to their size, but individually they don't have a lot of charge.
Why did we need FG? We use
It
that.
asks for it.
It belongs gravitational force, we haven't
That's what we're
solved for it.
solving.
Wait, sorry.
I'm about to solve for FG now.
I think you said this, but I was too new, so I couldn't do it enough. Did you say that like it comes out as negative, but you just put it as positive?
We wanted
You
magnitude.
take magnitude.
Wait, so is
Oh.
electric always gonna be positive then? Or only if it says by magnitude?
Okay.
If it says find the magnitude, but I'll show you in the next problem how we'll come into some situations where the negative. Okay? Now, you would have had to look up in your book what the mass of a proton and the mass of an electron is. For the sake of time, I'm just going to give you what the mass of a proton and the mass of an electron is, okay?
Okay.
The mass of an electron is 9 point, and you might want to write this in your notes so that you have it in case you need it in your homework at all. That's your electron, because it's the smaller of the two. Okay, and the distance is still the same.
The first one's electron.
First one's the electron because the smaller one is the electron. I don't know if you guys remember that the electron is the smallest of the 3 parts.
Isn't a neutron like almost the same as a neutron?
Yeah.
Close.
Okay. I know you guys can do math, so what I'm going to do is just give you the answer here. Now notice that the gravitational attraction between these two is a lot smaller than the electric attraction between these two objects. Yes.
Did we have this FG equation?
This is
before?
from chapter 7.
Chapter 7 is semester last.
Chapter 7 was last semester. It was the gravitational chapter.
Yeah.
Where did you get that big M?
What?
6.6.
This is the constant big G.
Oh.
It's been a while. It was chapter 7.
Where's that from?
Chapter 7.
Oh. Is it?
It's Newton, Sir Isaac Newton came up with this constant, and what he did, it was an earth-shattering discovery because it allowed him and anybody to figure out the gravitational attraction between any two objects. I can figure out the gravitational attraction between me and Isaac right now. I can figure out the distance between them, and I can figure out our masses. It actually is extremely strong, not strong, weak, because we have small masses relative to the big G. Questions on this? I want to get to the harder problem.
You
We have to have
gave
all
us
of
zero
these
space.
What? Memorize.
All of these numbers.
I want you to memorize that one. That shouldn't be too hard. I want you to memorize that one. We'll use these a lot. Trust me. We'll
So,
use these a lot.
Big M is your
I'll give you big G.
Big M is your electron and little m is your proton.
Well, it doesn't. Yeah. In this context, yes, but it doesn't matter which one you put where.
But just need to know that the M's are electrons.
I just want you to know that this is the electron. That's because it's the smaller of the two.
Yeah, I got that.
Okay, I want to spend some time doing this one because it is difficult. So please, I do want you to ask questions, okay? But don't try to jump the gun too much because usually I answer questions later as I'm going through them.
So this is considered.
Needs to think about.
Okay? So So here is the situation. I'm going to draw a picture of what is going on. Okay, we have a negative charge here, a positive charge here, and a positive charge here.
How do you know where to put them?
It's from the book, and I'm just writing the problem. You would never have to put them. They
Oh,
would
so
give
it would
to you.
show that to us?
Chemistry?
Yep.
I remember
This is not from chemistry.
this. No, like whatever it is. Yeah.
No, it's from
Wait,
physics.
No, it's-
Okay. Now, they gave us a few things. First off, again, they will give you the diagram. Okay. Q1, what did they tell us it was?
6.0 times 10 to the six.
Charge. Q. Q1, Q2.
Q1, Q2, Q3.
Times 10 to the 19.
Okay, some other information that they give us. The distance between these two guys is 3 meters. Again, they would give you all this information. I just didn't want to write it all up there to save some room. Okay, this is 5 meters. And this is 4 meters.
Oh, wait.
Okay? Everyone following so far? Okay?
Well, let's hope they're at vector length.
What?
Don't forget vector length.
Okay, and it says find the magnitude and direction of the forces that are acting on Q3. So I am trying to figure out the forces that are acting on Q3 from these two guys. Follow?
Okay.
So first thing I think you should do is just kind of figure out which way it's going to be pushed or pulled. Okay, so if I look at this one, okay, what is going to happen here?
Towards
Attract or repel?
Attract.
So this charge will get pulled that direction, yeah?
Yes.
Okay? How about this one?
It'll attract
Push away.
upward.
Push to the.
Oh, from
Right,
that one,
yeah.
yes.
That, right?
Yes.
Oh, because it goes away. Yeah, oh,
Right?
yeah, yeah.
Repels, attracts.
Yes.
Okay? And we are going to have to find the vector sum of that, which will look something like this. And we'll have to find its angle, but we'll get to that in a second. This is geometry. Okay? Just stay with me. The first thing we need to do is we need to find the forces, what the forces are. Okay? So I'll abbreviate it force on 3 by 1. And then we'll do a second one, force on 3 by 2. Everyone follow it.
Yeah.
So this is 3. This force will be from 1, and this force will be from, this force will be from 1, and this force will be from 2.
Yeah. This is
Okay.
Q1.
Our constant, yeah?
Yep.
Okay, now, we gotta find the 1 and 3 charge. That's what these are. Yeah?
Yeah.
And then we want the distance between 2 and 3, correct?
Which is just.
Yeah.
Just,
Yeah.
What is the distance between 2 and 3? 4 meters, and we gotta do what with it?
Square.
How come for the 3 and 2 ones you did not?
Wait,
Three's the top right.
Oh, I did it.
Oh,
You're right. Good catch. So there's 3, there should be,
Also, isn't that supposed to?
okay, I'm not putting a negative in there, and I will tell you why later. Okay? Alright? Okay, let's do the top one, 1 and 3. That's where the 6 and the 5 are. So what Autumn pointed out is I put the wrong charge in here.
So you put the
I put in
other
1
two
instead of
particles?
2. I needed to put 2 and 3 in here. This is what 2 and 3 are. I need to put 1 and 3 in here because we're talking about 1 and 3 here.
Okay,
Okay?
okay.
Okay, and since we're talking about 1 and 3, I need to put the distance between 1 and 3, which is 5. Square.
Why don't you?
Because I want to know the force is acting on Q3.
Okay, so you only want to.
Yeah, does everybody understand? I'm trying to figure out the forces on Q3, so what 1 and 2 do to each other is irrelevant. Okay?
Gotcha.
Does that agree with what you guys got?
I got 1.1 though. Where did you get R? Oh,
So that's the distance between my particular charges
yeah.
that I was looking
gotcha.
at. Okay? So, we would technically say that this force is this strong, and this force is that strong. Okay? However, one of them is not on the XY axis.
Oh, let's resolve this.
So one of them we have to resolve. Okay? So I'm going to draw this over here. We have to do vectors tip to tail.
That's not
Wait,
the right
Kramer?
proportions.
On that last one, I got 6 times 10 to the negative 9. Did you count that right? 'Cause my
This one?
Yeah. Mine didn't do the math. And the other one, it gave me 1.1. It rounded up. The vector one.
Oh, that's not good.
So you're just gonna put every math problem wrong.
Wait, try it. Okay, yeah, you're right. Oh, yeah.
I haven't plugged any of the numbers in, I can do this.
Those are extracted.
How bad soup, no, sorry.
And that's as a joke.
Which one?
No, chicken arms.
If you show your work, if you show your work, you'll be fine. That's annoying, but. Okay. So, what we now have to do is find our x components and our y components. Okay? We'll start with this one, which we said was this. We said this was this guy. Okay? Fx, Fy. We need to break this up into an x component and a y component. Please.
Why don't, you don't have to. I got keep getting one answer.
Yeah,
For the F3, F2.
yeah.
I keep getting to the negative 9.
That's what I keep doing.
Well,
It's okay.
Oh, yeah, it's -9. Sorry. I just made a typo. Everyone
No,
fix that.
yeah.
Both of them are just one?
Just the
Just
one. Okay? So to find the x, it's going to be cosine because it's adjacent. To find the y, it's going to be sine because it's opposite. Okay, now they'll give you this, but I forgot to write it up here. That angle is 37 degrees.
Wait,
Right?
actually,
So-
F32 is on top of F31.
Tip tail.
So this force caused that, which is the 3 and 1 force, and this is the 3 and 2 force, is that direction. I just did tip to tail. And I moved this so that it was tip to tail.
But that's
But
not
it's,
wrong.
it's
I know.
3 to 1.
This-
The
I thought for a
3 to 2
second
force
it
is the
was
one
going
when they go together,
something
correct?
first angle like
It
5
comes
meter, 4
left.
meter.
3,
Yeah.
2, 1 is
So
like
shouldn't
over
that be-
twice as big as the other
Now
one.
we'll go left.
Yeah, but should that be F31? Is that where 3 and 1 are? Cosine.
This one?
Yeah, 37. Because that's where they attract.
This is 2 and 3.
Oh, that's top is 2 or
Yeah.
Oh, I wrote that
That's a
down as
1.
1 here. I wrote, okay,
Okay.
opposite over
All right.
opposite.
Focus with me here. Okay, what's the magnitude of this? 1.08? times 10 to the negative 8. Okay, we said this is going to be our x, so that's going to be cosine of 37. And 1.08 sine of 37 will give me my x and y components. Your x component is 8.63 times 10 to the negative 9. And your y component is that.
What's the one?
That's not true. That's not it. That's the wrong number. I'm trying to save time and not make you write it all, put all this in your calculator. But I probably should get you the right numbers.
Kramer.
What?
What's the 1.08 times 10? Is that, okay, gotcha. Got it.
I'm just taking this vector and resolving it into an x and y component.
Oh, right.
This is x, this is y, because if I'm going to add these two, I better have them in the x and y components, because we're going to have to do an x total and a y total, just like we did last semester. Okay? Now, look at this guy. It's all what?
X.
It's all
Just straight.
x.
You just need to find how far it
Why is x cosine?
Oh, we already know.
X is cosine because cosine is adjacent and sine is opposite. This is the adjacent side, that's the opposite side from the angle position. Okay? Which means that this number is completely all x. What? Everybody understand why this vector was all x and I didn't have to resolve it? Because there was no y
There's no
component.
one.
This is straight horizontal. Now I didn't draw it very well, but over here you can see that that's straight horizontal.
Okay.
Okay?
So it's already on the x-axis.
Now what I need is an fx total and an fy total.
Kramer,
Yep.
you never told us why you didn't make those, the q's negative in.
I'm about to tell you right now.
Oh.
Okay? What I want you to do before you do an x total or a y total, I want you to go back and look at direction. Okay? This x, is it positive or negative?
Positive.
This y, is it positive or negative?
Positive.
So that means that's positive, or sorry, that's positive and that's positive. What about this x?
Negative.
So I gotta put the negative in there.
Why are you saying?
Because
Because you can, so that way you don't have to worry about the negatives here. You just at the end, look at the direction and use the direction to tell you what the negatives are.
Well, that always works.
Oh, I don't
This is the direction so you can see.
Is this a positive x? Direction wise.
Where's the direction?
I'm starting here and I'm going that way.
But
the
that's
tip
the
to tail.
axis.
Okay? I'm starting here and I'm going up. That's positive. Okay? Here's my starting point of this vector. Which way am I going? Negative. Left, which is negative. Okay, now let me finish. Fx total is going to be 8.63 times 10 to the negative 9. Okay? Minus, because that's negative. I'm going to keep you a little long here. And your Fy is only one number because there's only one y component. Okay, when you solve this, you get 3.01. All right, not done yet. Got two more things yet.
you did go in that room at all.
You just worked your way down.
I know.
Now we have the x sum and the y sum. I can find this vector now. Okay, if I take this and subtract this from it, I get about that much x.
Oh,
Yeah.
Okay? Now, how do you find the resultant vector? Pythagorean theorem. Is that an 8 or is that, wait, what?
Which kind
You're getting some
No.
so do you see?
That's the resultant vector.
Oh,
It's gonna be a little bit difficult if we struggle to stay on top of this when it was chapter 3.
The Pythagorean theorem.
It's just square.
I'm missing a plus sign in here. Also a square. It does have to be square, right? It's not what it is yet.
Or c squared, so he's
X,
taking the square root of
Y.
c by itself.
So your resultant vector, which would be your F3 total, the sum of both those vectors will be 7.16 times 10 to the negative 9. And then I want direction. You remember how to do direction?
It's tangent.
Inverse tangent.
How that number is.
But isn't that different?
So the angle is inverse tangent, okay, of TOA opposite over adjacent. My opposite will be my y and my adjacent will be my x. 6.5 will be on top. And 3.01 will be on bottom. So your angle, 65.2 degrees. And I will say above the positive x-axis.
This is on ACT. Totally. 40 minutes later.
Can confirm.
So your answer is the direction.
It's actually not.
Sorry, the answer is F3 total and the angle.
Yep. The sum of the two vectors, which we had to resolve one of them, and find the x total and the y total. The Pythagorean theorem gives us the sum. It ends up being this resultant vector, the sum of the two vectors.
What does that say above the plus?
Above the positive x-axis. If you want to put positive in there, you can.
See that little? No, I don't see anything. I don't see anything. I don't understand.
See, Jesse, if you can do that.
Hey,
Five.
Fire race that yet, Craig.
I do
I have a
have.
question, but
Here, let me help you here. Here you go. Here's vector 1.
wait. Let's see.
Here's vector 2. Okay? Here's the x component of vector 1, the x component of vector 2.
I forgot to use
I've been stung by a
Okay?
bee.
And I'm going to draw in green what the total one is. This is the resultant, which will be the y and the x. And you see if I take the x here and subtract the x here, I get this x.
Yes, but how did you know that was sort of?
By the numbers. That's all. Okay, so what I have is these two x's canceled out to give us only this little x. That's why we had to find the x total here. That's why I added this and subtracted this to get the total x, which is this little bit here. Okay, and we only had one y. That's why we only used the one y. And here's the Pythagorean theorem. Here's your right angle, or right triangle, and there's your angle that we figured out.
This
It was opposite over adjacent, inverse
So
tangent.
the 37 would give us
This
this.
one,
Why can't we just subtract 37?
well, that would be assuming if we wanted to find this side, not the result.
Life is a trap. I really wish I had like the class after this.
Yeah, so we have two forces out there. Again, what was look at this. You know, a force this way, wouldn't you say that the force is probably something like this, depending upon how strong that is and how strong that is, which is why our resultant vector ends up being like that.
We just kind of sit.
Should at least he was
Gone.
What? I noticed you were gone. Why not
I
say?
told you, I tried to tell you guys were okay.
Seemed like you
Didn't I say, well, Carly's not here, don't you remember that?
halfway through the class.
I mean, would you notice if I wasn't here?
Yeah.
I'm also loud and obnoxious.
The teacher was telling us. You know, maybe after school, like Tuesdays. I can tell you one person who goes for sure. You? Yeah.